recognize that the Earth is a vast laboratory where the mechanisms of natural selection have enabled evolutionary solutions to be developed for a wide range of problems. The difficulties that nature has evolved to cope with are often not the exact same ones that we face, but we can piggyback on the immense scope of natural experimentation and redeploy a solution to our advantage. If anyone should doubt the capabilities of evolutionary solutions, consider the humble housefly. These small insects, typically 5 to 7 millimeters, 0.2 to 0.3 inches long, are common wherever humans live around the world. Next time you see a housefly, try and catch it in your hand. The chances are that it will easily avoid your grasp. Our technology is amazing, yet we are very far from being able to build a robot the size of a housefly that can fly, walk, and evade an attempt to catch it. Nature has evolved solutions to problems that remain well beyond our technological grasp. All too often, the natural and the artificial are presented as opposing concepts, where everything natural is wonderful and the artificial is a poor second best, or even positively harmful. We should remember that artificial means made by human artifice, by skill. It's not a bad thing, and raw nature can be a distinctly nasty place. Equally, though, it would be big-headed in the extreme to think that we are incapable of learning from the world around us. Not only is the laboratory of nature huge, it has been carrying out evolutionary experiments for billions of years. Most of these experiments end in failure, but there have been so many tried that enough have worked and worked well that we could spend many generations attempting to discover the transferable concepts derivable from nature. To see how biomimetics can result in a simple yet highly practical solution to a problem, we will take a trip back in time to Switzerland. In 1941, an electrical engineer named George de Mestral, at the time aged 34, was out hunting in alpine woodland with his shotgun and his dog Milka. As they headed for home, he noticed that his socks and coat, along with Milka's fur, had picked up seed heads of the burdock plant, known as burrs. The ability of these burrs to hitch a ride was the result of one of evolution's many attempts to deal with a reproductive barrier faced by plants. Unlike animals, plants are static. By default, their seeds drop to the ground at the base of the plant. This is a problem because when the seeds germinate, they will be competing both with each other and the parent plant, attempting to access the same nutrients, sunlight, and water. It would be far better for reproductive success if the young plants could put some space between themselves and their parent. The way that evolution works is that traits that increase the chances that a species will successfully reproduce are more likely to be passed on to the next generation, and so on. Plants that developed mutations that gave them a slight edge in dealing with this problem lived to pass these mutations on, making the traits increasingly dominant. This has happened in a multitude of ways to deal with the seed distribution problem. There are many plants, for example, that make use of the air to spread their seeds. This approach ranges from wind-blown seeds, such as the dandelion's delicate clock seed head, to the helicopter-like wings found on some tree seeds, such as the sycamore, which enable the seeds to fly many meters from the tree. Other plants have made use of the mobility of animals to give their seeds a lift. Many do this by giving the seeds a sweet coating, making the package attractive to eat. As a result, the seeds get passed through the animal's digestive system to be deposited elsewhere. But there is an alternative approach. If a seed should happen to stick to an animal's coat, it can piggyback on the moving animal, dropping off at a later time when it has been carried away from its parent. And it is this approach that came to be used by the burdock. The heads of the plant, carrying seeds, are covered in little spines.